Hi, this is Mrs. Finnegan again, and I'm going to go over the section of the Semester 2 Pre-Cal review, final exam review, on multiple angle identities. So we're going to be looking at questions 61 through 64. And to do these sections, you want to make sure that you are familiar with your sum and difference identities as well as your double angle identities. And you could, as reference, look at your an identity formula chart if you have this written down in a foldable or this formula chart. This one is available at eeweb.com. If you go to their math tools, they have this. They also have several other trig, calculus, algebra, and geometry formula charts that could help you review different things that you need to. Not necessarily for this test, but in the future if you need some references. All right, so we're going to be using the sum and difference and the double angle identity sections of this formula chart. All right, so the first thing I'm going to do, I notice that I'm given two ratios, a sine and a cosine ratios for two angles, angle alpha and angle beta. And so what I'm going to do is I'm going to draw those angles on a coordinate grid and figure out what their reference triangle would be before I do anything else. So I'm going to take the first one, I'm going to draw angle A. I'm told it terminates in quadrant 4. So in quadrant 4, that means that the angle is going to come off somewhere around here, and the angle itself actually goes from 0 until here, and so that's our alpha angle. But in order to answer this problem, what it's doing is it's drawing a reference triangle back to the x-axis. And since we're dealing with sine, we know that sine is y over r, so the y portion of this triangle is going to be -5, while the r portion is going to be 13. Notice that I assigned the negative with the y portion as opposed to the radius, because radius is never going to be negative. It's only the x's and y's that are going to be negative. All right, so I could use Pythagorean theorem, or if you recognize that this is a Pythagorean triple triangle, it is a 5, 12, 13 triangle. Like I said, if you did not know that it was a Pythagorean triple triangle, which is a special ratio or set of values that always create a right triangle, then you can use Pythagorean theorem to figure out that missing side. All right, I'm also now going to graph the beta angle, and I'm told that beta terminates in quadrant 1, so this one's going to be nice and easy. So I'm going to go to quadrant 1, I'm going to draw a reference triangle, and my beta is actually just the angle that I would normally graph in the triangle. So in this one I'm given the cosine. Cosine is x over r, so my x is going to be 4 and my r is going to be 5, and I think everybody recognizes this one is going to be a 3, 4, 5 triangle. Alright, so based on that I can now create any sine, cosine, or tangent ratio that I need in order to answer my question. Alright, so the first question we're going to answer is the sine of alpha minus beta. So first off, I notice that I am subtracting two angles, so I'm going to use the difference of the difference identity. So whenever we're doing the sine difference identity, then our sine is going to be the same. If we're subtracting here, we're subtracting there, but we're going to have sine A cosine beta minus cosine alpha sine beta. All right, so even though we're going to switch up the trig, and we're going to keep the sine the same. So here's our difference of angles identity applied. And so now all I have to do is use my triangles to substitute in the sine or cosine ratio appropriate for each one. So sine alpha we already were given as -5 over 13, and cosine beta is 4 over 5, so I'm going to plug those in. And I'm going to get the cosine alpha from the alpha triangle that I drew. Cosine is going to be x over r, so it's going to be 12 over 13. And the sine beta is going to come from my beta triangle that I drew, which is going to be my y over r, so it's going to be 3 over 5. Alright, so now I've plugged in all of my ratios. I'm going to multiply the fractions together and then combine the two together. Okay, so the first two fractions multiplied together are going to become -20 over 65, and then 12/13 times 3/5 is going to be -36 over 65. Since they have the same denominator, it makes this nice and easy for us. The denominator is going to be 65, and I can just combine the numerators. So -20 minus 36 is going to be -56 over 65. I always want to double check to make sure that I don't have any common factors. Factors of 56 are going to be 7 and 8. Factors of 65 are 13 and 5, so this will not simplify. So my final answer then is going to be -56 over 65. Okay, so now let's look at question number 62. Here we're going to do the tangent of alpha plus beta. So we're going to go to our sum difference identity, and we're going to use the tangent one. On the tangent identity, you need to be a little bit more careful about how you assign the signs. Okay, so here, on the way this formula sheet works, whatever sign is on top inside of my parentheses, I use the top sign over here. So the sum identity for tangent is going to be tangent alpha plus tangent beta, but in the denominator, I'm going to use a minus sign. So 1 minus tangent alpha tangent beta. So whenever you're applying the tangent sum or difference identity, the sign in the numerator is going to match the sign in your parentheses, but the sign in the denominator is going to be opposite. Okay, so over here I'm going to pull up the identity. Alright, so here it is, tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Okay, so I'm going to now replace the tangents with their ratio based on the triangles that we built a little bit ago. So tangent alpha, remember tangent is y over x, is going to be negative 5 over 12. And tangent beta is going to be y over x, which is 3 over 4. And that's going to be the same for anytime I see tangent alpha or tangent beta. So I'm going to plug those in. Okay, so now that I have the ratios plugged in, I need to make sure that I get a common denominator in the numerator. So the closest denominator I could get would be 12, but since I look at the denominator of the big fraction, I'm going to see that 12 times 4 is going to give me 48, so I might as well go ahead and make the denominator of the numerator 48. If you make it 12, you'll still wind up with the same answer. So that means I'm going to have to multiply to get 48, so that's going to be 4 times 4, and this one's going to be 12 over 12. And then I'm also going to change the 1 to have a denominator of 48. So let me go ahead and make those changes. Okay, so this gives me negative 20 over 48. 3/4 becomes 36 over 48. 1 becomes 48 over 48. And these two multiplied together give me 15 over 48. Notice since I had a negative sign and a minus sign, I went ahead and turned it into a plus sign. So now let's go ahead and add the numerator together. So we're going to get 16 over 48. And the denominator combined is going to be 48 plus 15 is 63 over 48. Alright, so now to get my final answer, what I'm going to do, since I'm dividing by a fraction, I'm going to multiply by its reciprocal. So I have the numerator 16 over 48, and it's going to be times 48 over 63. And because I already had my two denominators matching, when I multiply by the reciprocal, those are going to cancel out, and I'm going to be left with 16 over 63. I always want to do a last second double check to make sure I have no common factors. Factors of 16 are going to be 4 and 4. Factors of 63 are going to be 7 and 9. So no common factors. So 16 over 63 is my final answer on that one. Sorry about that. Alright, so now let's go ahead and look at the cosine of 2a. 2 times alpha is a double angle, so I'm going to, instead of using my sum difference identities, I'm going to go up a little bit and I'm going to use my double angle identities. Alright, so anytime I say 2 times an angle inside, I'm going to use one of these angles identities. So cosine, I can pick whichever 3 of these I want. Alright, based off what I know, how comfortable I am with multiplication. Regardless of which one you use, you'll wind up with the same answer. So I'm going to use the cosine squared minus sine squared identity. You are welcome to use any of the others if you like. But I'm going to use this one because I wind up with two fractions with the same denominator, whereas over here I'm subtracting one, and which I would have to change to have a common denominator. Alright, so I've replaced cosine of 2 alpha with the identity cosine squared theta minus sine squared theta. And if I rewrite it, I'm going to replace theta with alpha. And anytime I'm squaring cosine or sine, it's the same as if I put the square outside of my parentheses. So I could say cosine alpha parentheses squared minus sine alpha parentheses squared. Alright, now that I've rewritten it, it's going to make it a little bit easier to plug stuff in. So I'm only using the alpha triangle. So cosine alpha is going to be 12 over 13. And sine alpha is going to be negative 5 over 12. Sorry, negative 5 over 13. because it's y over r. Okay, those are both going to be squared, so let me go ahead and square it. Remember, whenever you square a negative number, it becomes positive. Okay, so I get 144 over 169 minus 25 over 169. So now I can, since they have a common denominator already, I can just go ahead and subtract my numerator, which is going to give me 119 over 169. Neither one of those are going to have any common denominators, so that is the simplest, and that will be my final answer. I cannot simplify it any further. If you had used any of the other two double angle identities for cosine, you would ultimately wind up with the same thing. You just don't have the convenience of having the same denominator by choosing the identity that I did.